Hey everyone, this is Judy Warner with Altium's OnTrack Podcast. Thanks for joining again. If you would, please connect with me on LinkedIn. I like to share lots of information relative to PCB designers and engineers who are laying out boards. And on Twitter, I'm at Altium Judy, and Altium is on all the usual places, Facebook, LinkedIn, and Twitter. So please let us know what you'd like to hear about on the podcast, and we will do our best to get it done. So today I have a rock star with us, and he needs no introduction. But before we get going with Dr. Eric Bogatin, I wanted to say that a few weeks back I had put a challenge out there to see if you guys could guess how many countries the OnTrack podcast has reached. And we have a winner. So congratulations to Dawood Zas. He's a senior staff engineer at Dexcom. He guessed 37 countries, and he was the closest one. Unfortunately, it was only about half, because we've actually reached 84 countries. I kid you not. So anyways, thank you for listening and engaging with us and all across the world. We really appreciate it. So today, as I mentioned, we have Dr. Eric Bogatin with us, who needs no introduction, who is a signal integrity guru. You might know him from many conferences in North America, and I suppose around the world. Eric has presented. And I'm lucky enough to be here in California, where I've seen him present many times on Be the Signal. And now the Be the Signal and Eric Bogatin brand is now flying under the Teledyne LaCroix flag. So he has lots of lectures and demos and things, and I'll let him tell you more about that. So, Eric, welcome. We are glad to have you.
Hey, thanks, Judy. I'm happy to be here with you today and tell you about all the things I've got going on.
Well, we're super excited to have you as a keynote at Altium Live. So we really appreciate you coming out for that. And we've done some neat things together with students, so we'll talk more about that. So why don't you start off by telling us a little bit about your day job at Teledyne LaCroix?
Sure. Yeah, so many of you may know, and I know you. I knew you back when I had my own company. It was Bogatin Enterprises, and I literally went around the world and did training classes. And about 7 years ago, my training company was acquired by LaCroix, and we continued the training classes and then began to make a slight transition to, most of what I've done over the years has been best design practices, how to get the design right the first time. And LaCroix is in the measurement business. We are the third largest manufacturer of oscilloscopes and some of the highest end oscilloscopes. And our CTO Dave Graff, he likes to say that in designing, the goal is to get it right the first time. But if you don't get it right the first time, then the goal is to get it right the second time. and the way you get it right the second time is you have to find the root cause of the problem. And invariably that involves measurement. So that's kind of the connection with LaCroix is we're number 3 in the scope world and have the highest end, highest performance scopes out there. We really specialize in the business of kind of helping customers get it right the second time, kind of a faster time to insight. And so we started out, when I joined them 7 years ago, doing the same best design practices presentations and classes I used to do. And then over the years since then, I've been working on this new area of best measurement practices. And so with my day job at Teledyne LaCroix, I'm still signal integrity evangelist, but I spend more time now going around talking to folks about and doing presentations on what are some of the best measurement practices. How do you kind of get the answer to either the performance or the root cause or the characterization or get the figure of merit? How do you get that as quickly as possible? And recently, in fact, I've got a couple of live events in the Bay Area coming up in actually next week, in last week in August, and then in Boston in September. And you can check the Teledyne LaCroix website for the events page to see where I'm coming next. But those presentations are really focused on how do you I call it kind of two aspects in best measurement practice. One is situational awareness. How do you pay attention to, how do you know what the performance of your instrument is so that you understand what its capabilities are, so you know what your device is doing compared to your instrument, so you make sure that you're not seeing an artifact in the measurement.
Oh,
so
that's interesting.
Situational, because I find in talking to a lot of folks about measurements, gosh, there's a lot of confusion about what's the scope doing, and unfortunately there is no such thing as the ideal instrument. There are always or ideal probe for that matter. There are always interactions of the probe and the scope with the device we're looking at. And it's important to understand what the properties of your scope and the probe are to know how far away you are from the properties of the device you're testing, so that you're getting good quality information about the device you care about and not an artifact of how you're doing the measurement. So that's the first piece of what we try to present and teach, those principles. And the second piece is, and I see this with my students all the time, that they sometimes feel that just getting the data, just getting the measurement is enough. So they, push the right buttons and they get a screenshot and say, okay, here's my data, and I see a lot of engineers doing that as well. And the data is just the starting place. You're not done with the data. You need to take that data, the measurement, and turn it into information. So you need to extract out what's a few pieces of valuable information, like what's the rise time, or what's the frequency, or what's the jitter. It's a figure of merit that takes a lot of data and gives you one or two numbers that you can do something with. I was given a talk at one of my events a couple weeks ago, and I was mentioning that we have this huge amount of data in a scope. I mean, one acquisition we can take up to 5 gigasamples worth of data, but it's typically maybe 10, 20 mega samples, but that's 10 or 20 million data points in one acquisition. It's a huge amount of data, but you only want one or two numbers out of it. And so I used to call it data mining, and someone said, hey, with all that data there, it's not mining, it's excavating. So it's kind of excavating the data for useful information. And then the third piece, once you have the information, is the so what. It's how do you turn that information into action? How do you use the information you've got to tell you, is this good or bad? Should I, raise the line width or decrease the line width? What do I want to do with that information now? How am I going to use that to influence a decision? So it's those 3 steps that we talk about in our workshops of how do you get the information so you have high quality of confidence, or the data so you have high confidence in it. How do you turn that data into information, extract the couple of figures of merit, the nuggets of valuable information, and how do you take that information and turn it into action? So that's what I'm focusing on these days, the idea of best measurement practices, in addition to the stuff I've done forever of best design practices. So that's kind of what I'm involved now, spending a lot of time going around doing live demonstrations, incorporating them in my workshops now. We've got some really cool scopes, and we bring a lot of test vehicles and structures so we can do live measurements of various signals. And so it's always a lot of fun when you can have a
physical scope there, right?
Yeah, a working device and the scope, and then people that come to these, I love working the crowd, and we talk about, well, if that's really what's going on, if you made the rise time shorter, what will you see? Or if I expanded the time base, what's the signal going to look like? And so we can do that as a live experiment in the group. So there's a lot of fun, very interactive activities. So that's what I do as my day job now.
Well, that's a lot, and you make it sound really fun and engaging. So also, Teledyne LaCroix will have a table at Altium Live. I hope we can talk you guys into bringing oscilloscope, so we'll let you work our crowd. And I'm sure you. Another thing, oh, by the way, I would encourage people that are listening to connect with Eric on LinkedIn or connect with me. I've been sharing those classes that Eric is teaching. So you'll be able to pick those up and see the different locations that he's teaching those courses. And we will also add those links below here in the show notes. So if you're in those areas, you can hop into one of Eric's classes. And he's super fun to... It's a very plain spoken, like I can learn things from Eric Bogatin. And I am not, my technical prowess is limited. So I really appreciate that about Eric. The other thing you do, we have some friends in common, which are Horizon House, the publishers of Microwave Journal, have published a new magazine called the SI Journal, which I'm very excited about. And you are also the editor of SI Journal. And we have a friend in common, Janine Love and Pat Hindle, and the whole group. I used to write a blog for Microwave Journal that is put out by the same publishers on their website, talking about making RF boards and all the fun that goes along with that. And so now Eric is editor of SI Journal. So you can also subscribe to that online. We will also share that link. So how's that been so far? Tell us about your...
Yeah.
How long has it been now? It hasn't been too terribly long.
You know what? I think it was it's almost 2 years now.
Wow, I was going to say a year, and it's like 2 years. Wow.
So I think between Pat and Janine, they kind of came up with it. They've been focusing on the Microwave Journal, which has been around for 30-some years, and is one of the, I think it's the top industry journal.
I think it's like 60 years or something.
Is it 60 years?
I don't know. I might be...
Okay, it's a long time.
It's a long time. It's been around forever.
And it's been a real icon in the industry for good technical quality articles about microwave technology. And with Janine's experience with DesignCon and in the signal integrity world, I think between she and Pat, they realized, hey, the industry could really use another curated source of high value information. And so many of the magazines that we're used to getting the print magazines have disappeared, and they're all online. And so Pat and Jean decided to create this as an online journal initially, and they asked me to come on board as the editor, really the technical editor, right at the beginning of about 2 years ago. And so since then we've been kind of planning it out, putting together the editorial review board or of really some industry heavyweights, and kind of creating a lot of new content, soliciting content from other experts in the industry. In fact, while I have a captive audience here, if anybody out there listening is interested in writing a technical article for us, that'd be great. Drop me an email or send it through Judy, and I'd be happy to take a look at what you'd like to do. We created this, and our focus is to provide high-value content that's curated. That there is so much information out there online right now. If you do a Google search on signal integrity or power integrity, it's not that you don't find anything. You find like 10 gazillion different sources.
You get flooded.
You get flooded, and it's hard to know what's the good stuff and what's the stuff that I shouldn't waste my time with. And so I think that's really the value of having a online publication, a portal that is curated. And that's what we try to do is between myself and Jeannie and Pat and the editorial advisory board, we try to curate the content so that it's, in our opinion, what we would consider to be high value content. And so we don't want to waste people's time or our own time, and so there's, we think, a lot of really good, valuable content. We've done the traditional stuff of short columns, of feature-length articles. Janine manages the annual conference, the EDICon, which is now coming to the Santa Clara area in October. I think it's a couple weeks after the
it is. It's really close.
Event. And part of that is now, I think Gene's calling it the EDICon University, which is going to be tutorials by industry experts that are available for all the attendees. And then she also manages webinars. And if I can just plug a previous webinar, so we had Rick Hartley do a webinar.
Which we love, and as I mentioned, Rick
Yeah,
will be, you and Rick are just so well respected in the SI field, so I'm glad you snatched him up.
Yes, we got him to do one a couple months ago, and that's recorded and posted on the SI Journal.
Oh, great.
And then I did one a couple weeks ago that's also up there. So we have maybe it's 20 or 30 different webinars, and they're all free and all available for anybody. If you go to the sijournal.com website and you can look under videos and webinars, anybody can access all the content on the SI Journal is free as well.
So there's some other people that are dear friends. Bert Simonovich, I know, is on your team on the magazine. Who I think is Yuri?
Yeah,
on that team as well.
Yeah, Yuri's been involved. Istvan Novak has been on the editorial advisory board. We just brought on Steve Sandler. Let's see, Larry Smith, who is he's my buddy. We worked on a book together that came out last year on power integrity, and he now is at Micron. Used to be at Qualcomm.
Mm-hmm.
He's maybe the one or two world expert on power integrity. So I learned a lot working with Larry. Let's see. So so those are the
they're
main
all
folks.
Heavy hitters. All
it's the
really
industry experts.
They are the industry experts. So you really have kudos to Horizon House for putting together such a crack team with you at the helm, which is just incredible. And like you said, curating that content because there's so much noise out there.
Right.
How do we bring the noise down and just cherry pick the best pieces? And I was kind of around when before and as they were launching EDICon, and I was really glad to see them, as high-speed digital and the RF world kind of move together, and some of the challenges were kind of overlapping. To launch a show like EDICon, I think, is really exciting, and this magazine. So, yay! Very excited about that. So I can't. And again, we'll put all these links below. I'll see if I'll go pluck out some of those webinars and put those links into if you didn't send those to me already.
So while I'm plugging webinars, can I plug one other webinar too?
I
should have mentioned it. So I've been spending a lot of time, too much time traveling, doing these live events, but also doing webinars. I mentioned the one with SI Journal.
Mm-hmm.
I've also been doing some through LaCroix, and we have a whole landing page of
webinars
that LaCroix's done.
Yeah, there's a lot there.
There's a lot of high-value content that's all free. Anybody can view them, and I'm hoping you'll put up a link to
I will, definitely.
The webinar page from LaCroix as well.
Okay.
I've put a series together on a little bit about fundamentals of measurements. Part of this best measurement practices series that I mentioned earlier. They're 1-hour webinars on various scope measurement principles, and I'm doing them on a regular basis. I think we have 2 or 3 more scheduled for the rest of this year, and then we'll have another series starting up in January.
Exciting. I like the idea of this best measurement practices. It's like really practical.
Yeah, and it's the same thing with design practices. There are accepted practices that you want to follow, unless you have a strong, compelling reason otherwise. These are the right ways of doing things.
Right.
And same thing with measurement. There are just as many ways of screwing up a measurement as there is a design, and so you got to pay attention to both of them.
And there's a human in the loop too, besides your probe and all that. So.
Absolutely.
So if the human isn't. Tuned up.
So one of the principles that I teach in my graduate students at university and also engineers I talk to is I call it rule number 9. And have I talked to you about rule number 9 before? Oh, okay. I'm definitely going to be mentioning it at my keynote.
Okay.
Because I think it's one of the most important rules for any engineer. And basically it says before you do a measurement or simulation, you want to first think about what you expect to see. And I have found that to be the most valuable kind of habit to get into, because just like you said, when there's a human involved, it's easy to make a mistake.
Mm-hmm.
And how do you know that you don't have the connector connected where it should be? Or how do you know that I think I'm looking on channel 2, but I'm really looking on channel 3?
Yeah.
Or I typed in 17, but I meant 71. How do you know that you can check yourself, but there's a limit to how well you can check yourself? And so if you think about what you expect to see ahead of time, whether measurement or simulation, and look at the result, and if it's not what you expect, there's always a reason for it. And you shouldn't proceed with that information until you've identified how come it's not what I expect. And when I do these live demos in front of the groups, I'm constantly making mistakes because I was under pressure. I got to screw in that connector, and I'm not sure which demo am I on right now. And so I'm always looking at the screen to see, is it what I expect to see? And I can tell instantly when I've done something wrong because I used rule number 9. And I sometimes play a game with the audience, the engineers there, and say, okay, we expected to see this waveform go up and then down, and it's flat. How come? And it's a good experience, good practice at that, thinking of what could go wrong in the debugging process, because that's what we all end up doing. And the more experienced we can become at finding the root cause and why it's not what we expect, I think the quicker we can get to a good answer and move on to the next problem. So it's an incredibly powerful habit that I use all the time. And I try to teach all my students.
This is what I love about your classes and things you teach, Eric. I've sat in a few of them over the years, is that they're insanely practical and intuitive and memorable. Like rule number 9, I can remember that, right? It's so I really appreciate it about you. Well,
and of course, don't forget, I also reinforce good behavior with chocolate. So that. Oh,
yeah, he does. He throws chocolate out at his classes. So yeah, it does. It's like Pavlov's dogs. Too. Yeah, it's so true. Yeah. Well, I wanted to jump into the way that you and I started working together. Is I think a month or two ago, iConnect 007 came out with a magazine with an empty pair of shoes walking down the street, and it said, "Who's going to fill your shoes?" And everybody seems to get on this bandwagon about all the people that really fundamentally understand PCB design in regards to not just designing, but manufacturing, assembly, the whole, all the stakeholders that are kind of implied in that process are graying and going to retire. And so, there's been studies out by UP Media saying, by a pretty large sample, saying that in under 10 years, half of PCB designers are going to be gone. And so everyone's sort of gotten to this hysteria about, it seems like the unanswerable question. What I appreciate that you've done is, I'm going to call you Professor now. He wears lots of hats. Professor Bogatin called me up and said, Judy, I'm going to do this program. He's used different tools right now that I think the students were sort of driving, or somebody was driving one at All Team Designer. So you kicked off this amazing semester-long course and at the University of Colorado Boulder. And you, I think, co-teach that, right, Eric?
Yeah, so I can give you the quick history here.
Okay, let's hear it.
So I've been teaching a graduate signal integrity class at CU Boulder for a number of years based on my textbook. And in talking to folks there, we realized that our students, so CU Boulder tends to be very project-oriented, very hands-on.
Okay.
We believe in that, you learn from textbooks, you learn from studying, but you understand by doing. Mm-hmm. And it's the hands-on part that you really, everything comes together. And there were a number of classes that required building circuit boards. And I would get called in as a consultant to help them in designing the circuit boards. And they're relatively simple boards, 2-layer boards. But these kids had absolutely no idea. They could push the buttons on the tool, but they had absolutely no idea how the performance it was influenced by what they do in the layout. And so it became really clear that, boy, it sure would help if they had a little bit of guidance in how to design boards correctly. And so a number of us got together and realized, hey, we need this more formal training. And a buddy of mine, Mike Horowitz, who is an expert at designing circuit boards, we got together and put this course together, which was, and it's kind of a funny organization too. We're also trying another experiment at CU. We're semester based, and so our courses are typically like 15 weeks or so. But we are experimenting with creating short 5-week modules. So it'll be the full regular course that is normal schedule of 3 hours per week, but it only lasts for 5 weeks. And so Mike and I were tasked with putting a course on printed circuit board design and manufacture together that would have a 5-week beginning piece that could be a standalone, so that most students, undergraduates, would take that, and that'd be enough to get them going on their projects, and then everybody else would continue for the rest of the 10 weeks, and that would go into more detail, so it would get them more experienced at circuit board design. And so that's how it got started, and Mike and I worked on it it's every semester, so we did it twice last year, and now so that was kind of our kind of joint development, and now Mike has gotten more involved in his CEO activities, and so I'm going to solo it this semester.
Oh, okay.
So the format is basically a 5-week crash course on how to design a board so you have a good chance of success when you build a 2-layer board. And then the other 5 weeks are more of the same, more of the technical detail about measurement this idea of the best measurement practices. How do you bring up a board? How do you design a board for simple test and bring up? And then we'll do 4-layer boards, and then a little bit on more high performance systems. So it's a little bit more advanced. And really, the way we've positioned it as there are 2 levels of design. The first is, if you can build a prototype and build it with a solderless breadboard and have wires going all over the place, if that works, then designing the circuit board and having it work is really straightforward. We call it designing just for connectivity. Okay. You don't have to worry about performance. It's about, you want to be able to manufacture it, but performance is the interconnects don't matter. And some of the student designs are just designed for connectivity. It's just about driving the board so you can find the parts in the library and build them in the schematic and then place them on the board and lay them out so you can assemble it by hand. Pretty straightforward. But many of our student designs these days are getting more sophisticated. They use Wi-Fi connections, so you have RF on the board. They have sensitive analog to digital converters on the boards. They have components, sometimes even BGA components, where the microcontrollers they're using are really fine pitch, hard to design by hand. And some of these have a couple nanosecond edges where ground bounce is a tremendous problem. And so we're focusing our class on how to design a board not just for connectivity, that's the easy part, but for performance, so that you can design it so it's manufacturable, it's lower cost, reduce so much of it is risk management, and then kind of the basic performance issues to worry about. And in my keynote, I'm thinking that I will probably present on what we have found to be the 2 most impactful design issues in designing a board not for connectivity but for performance. If all you think about is connectivity, you're going to run into 2 significant problems. And so one of the topics is this idea of rethinking how signals propagate on interconnects. And I've done this I did it at PCB West, and I did it at some of my other courses, and I had a couple people come up to me afterwards and tell me that it was a life-changing moment for them because I completely changed the way they've been working on boards for 20 years, and I completely changed how they thought about signals on boards. So I hope it will have a similar impact at Altium Live, but it's going to be about how to rethink and how to train your intuition to think about how signals really propagate on interconnects.
I loved your be the signal.
Yes, that's a key piece of it.
So, and
Zen.
I'm sure this is a little bit more complex than what you're going to present, but I remember the first time I ever sat in a course by Eric Bogatin, and he was talking about be the signal, and he's like, if this signal is moving from A to B, what do you think is going to happen? And I'm sitting there as a non-designer, and he's like, no, be the signal. What would you do? And kind of helped us to frame, kind of this visual. And I'm a visual person, so like to kind of visualize, what the things that were going on, in that signal path to create whatever it was. So I really love that. And
that's basically what I'm going to be talking about, that Zen approach to thinking about signals propagating and how to apply, I'll probably mention it once in my talk, but how to apply Maxwell's equations, but in an intuitive way to understand what's really going on in the interconnect.
Well, so Eric's talk is called Living in the White Space, and that will be relative to signal propagation, and I'm sure all of us, our brain will explode a little. I have these moments with Rick Hartley from time to time too, where he says something and I'm like, nah, it could be that simple or whatever. And I'm sure, Rick Hartley is a student of Eric Bogatin, so I'm sure it's more of the same. So, well, I really appreciate you, Eric, taking on these students at university level here at Altium is absolutely I think I would do this part of my job for free, is to help students get equipped with not only tools, like I can give them free tools, but that's a really incomplete model, for them to learn. They're learning about electrical theory in school, but really how to design a board and how does I just finished a podcast today with Julie Ellis, who's a field applications engineer from TTM. What about stack up? What about, all these variables and that come into play that are not taught at university, but I love that you've brought them in at a university level, because I think these are the kids. I think these are exactly who's going to fill some of those shoes. And they may be EEs that are laying out boards. They may end up like Rick Hartley did, saying, I like just designing boards better than circuit design. Who knows? We don't know. What has been some of your surprises, by the way? What feedback from students?
So I think two things absolutely surprised me is one is their lack of experience with oscilloscopes. That their way of using oscilloscope is first to push the auto scale button, and I slap their wrist if I catch them doing that, or pushing every button without knowing what it is until they see something. That they
until the light goes on.
Yeah,
they're looking for the
LED.
See
something on the screen. Yeah, and so they. Just the basic understanding of what an oscilloscope does and how to control the vertical and horizontal and the trigger, the very basic things. A lot of these kids, nobody's ever sat them down and talked to them about. So we focus on good, again, best measurement practices in the class as well as the design. The second thing is, there is a disconnect between what you learn in the textbook and what you see in the real world.
Huge.
And it's the same thing, but you have to know how to apply what you learn in the textbook. And I don't think any university does enough of that hands-on real-world activity. We try to do it a lot at CU. We have a lot of projects that students get involved in. Most of them are really about designing a little robot or designing some widget that does something with the code that you write in there. So a lot of it is software as well as the hardware. But in our class, we try to close the loop of here I do an estimate or calculation, and here I do a measurement. Like one of the first labs we do is blowing up traces.
That's fun.
It is.
Everybody likes blowing up something.
Everybody likes to blow shit up or stuff up. And so the first question I asked them is, okay, you're going to lay out a board and you're going to put some trace on it. What line width should you use? You can select it to be anything you want. What line width should you use? And so one of the things that surprised me is when I started asking students is they thought that a 6 mil wide line, which is the narrowest that most fab shops will do, a 6 mil wide line was too narrow because it had way too much resistance, or I can't put more than a couple milliamps of current through it, so I gotta use a 20 mil wide line or 50 mil wide line. And it's the kind of thing that the very first day in class we calculate, or we look at how do you calculate the resistance of a trace, how do you calculate what the maximum current handling it is using the IPC guidelines that Doug Brooks has been so heavily involved. And when you put in the numbers, you realize, oh my gosh, it looks really narrow on this board. It's only 6 mil wide, but gosh, its resistance is going to be still in the tens, hundreds of milliohms for typical lengths. So it really isn't that higher resistance, even though it looks really narrow, because copper is an incredibly good conductor.
Exactly.
People don't have good calibration of that. And then, so I'll give you the number, and I hope none of my students are listening to this because they're going to figure it out in class, but if you look in the IPC specs for maximum current handling for a 6 mil wide surface trace, it's like 2 amps or 3 amps. And when we put 2 amps through, we have a test board with different line widths on them. When you put 2 amps through it, you find we can monitor the voltage across it with constant current and see the voltage increasing because it gets hotter. So you see the beginning of the runaway. And darned if around 3 amps, IPC is around 2 amps, around 3 amps, darned if it doesn't go to thermal runaway and we zap the trace. And so, you can really get a good estimate by putting in the numbers ahead of time of how some of these interconnects are going to behave. But it's that habit of putting in the numbers, doing simple estimates, applying what we learn in class to the real world that the students don't have that good experience with, and that's what we try to do in our class at CU.
Well, to your point of hands-on, I feel like that's something that, for whatever reason, has left our education system too much, right? There's no shop at school anymore. There's no metal. There's no and it's not just what they would consider low labor skills or whatever. It's just hands-on learning, the kinesthetics of it. Because I bet you dollars to donuts that kid is going to remember blowing up a 3 amp trace more than if he read something about it in a book. Right? And sees the smoke and it pops and, there's this feedback. Well, what I was telling you about is, again, one of my favorite parts of my job is we just came back about 3 weeks ago from filming these kids that are doing the Hyperloop competition. I'm going to send you this video, Eric. You're going to die. Because what they do is so awesome, and it's just because they get to do hands-on. And they make a good, there's no way they're not making, more mistakes per minute than everybody else, right, in their field. But because of that, and because the lack of constraints they have on them as far as businesses and law and whatever, this one team we sponsor is from Munich, Germany. They just broke the world speed record inside the tube that Elon built at 290 miles per hour.
Wow.
Crushing. There's commercial companies with venture capitalists that haven't hit that number because they're young and they're hungry and they're hands-on and they're excited.
Yeah.
But these are the kids too, I think. I think there needs to be much more of what you're doing. I wish every university would, hopefully you'll set an example that others will follow. And by the way, I've cited your course to a group of 6 universities. I was invited to speak at UCSD. UC Davis was there, 5 other universities, and I put a screenshot of your course.
And that's great.
And so if you start getting weird phone calls, it's because I'm like, see what he's doing? You all need to do this, And so hopefully the word will spread. But until that happens, things like the Hyperloop competition, the FSAA competition, where kids get to get their hands on it and blow stuff up. Yeah. And do it wrong until they do it right, and learn how to use an oscilloscope in this really hands-on manner. Well, these kids are coming out of college, and the internships of these kids, one of these kids from University of Wisconsin in the Hyperloop team, he's at Qualcomm right now. The team lead is going to SpaceX on an internship.
Wow.
Companies are plucking them out because of the hands-on. So I think the more we sort of beat this drum and spread this message, I again, something I'm very passionate about, and I know you are too, and thank you so much for doing that course. And we cannot wait to hear from you and about living in the white space at Altium Live. Thank you so much for taking time out of your busy schedule.
Well, I look forward to seeing you at Altium Live and all the other viewers that you have. And I hope folks come up and say hi while I'm over there. Okay, will do. And see if we can get Hillary and company to bring out an oscilloscope so you can... We will definitely have one at our table. Okay, good, because I think that would be something notable and something that the attendees would enjoy. So thank you again, Eric. This has been... my pleasure, Judy. Thank you. Again, this has been Judy Warner with Altium's OnTrack Podcast and Dr. Eric Bogatin of Teledyne LaCroix. We look forward to being with you next time. Until then, remember to always stay on track.